Hello everyone, welcome back to fault tolerant tutorials. Today I'm gonna show you how to make use of the power of GPU in your Python program. In one of my recent projects with this big data and AI, we had an algorithm which contains a lot of mathematical computations and calculations, and we found that while running this program it was taking too much time and too much CPU cycles, literally overloading the CPU of the server. So we had to improvise and we need to figure out a way to do this calculation in much simpler, effective way. And the only way we can do as of now is with the help of GPU, this graphic processing unit. It's nothing but your graphics card, maybe from NVIDIA or ATI Radeon. And being Python being my favorite language, we found that with the help of two libraries, we can do these calculations in the GPU. And in this tutorial I'm going to show you how to do it with the help of a small example, and we will be comparing the results of the program in the CPU and in the GPU in the end of the tutorial. Alright, first thing first, we need to have the hardware installed with the latest library on it. So what I'm using here is NVIDIA's GTX 1060 with version number 3.20.3.63. I think this is the latest version. Anyway, just update it if you didn't have updated recently. I am using Microsoft Visual Studio Code as the IDE for my Python program. Let us open a new file named testcpu.py into the working folder, and here I am going to use numpy library to do a multiplication of two arrays. And okay, as usual, let's import the library numpy as np, then define a function which will have three arrays abc, and inside the function let's do a for loop which will iterate through the range of size of the array a and do the multiplication and put the values back into the array c. So c of I is equal to a of I into b of I. Now let's define the main function. A equal to b equal to np dot random samples of like a big size. So we'll just I don't know exactly which size we can put, so we'll give a variable called vec size. So vec underscore size is equal to, let's put some random numbers like 10,000 or 1 million, and then np dot random sample vec size, and data type is equal to float 32. Let's see, c is equal to np dot zeros of vec size, data type is equal to np dot float 32. Here all the arrays a, b, comma c, all the array sizes will be of the same size, and the size will be defined by the variable vec underscore size. Now let's put a timer there to calculate the time taken for the execution of the above calculation. So from timeit import default timer as timer, and then put the now time, current time, into a variable called start. Start is equal to timer. It will put the current time into a variable start, and then do the function called the function p of a comma b comma c, and then duration is equal to start minus current present time. So it will give the time which taken for execution of the above function. Then you can print time taken by CPU is equal to duration, and remaining, let's clean up the remaining codes of the Python and then try to execute and see if it is working or not. So if you see, the current vector size is given a number. I don't know how much it is. Let's see. And if you give execute python test cpu.py, there's an error there on line 14. I think I made a typo mistake there. Yeah, float np.float 32. And if you execute it properly, the current time taken by the CPU is 0.3 seconds. It's too small, so I will increase the vector size to get a reasonable time for analyzing the speed. Okay, then after changing the time vector size, I execute the program again, python test cpu.py. It's taking approximately 30 seconds. 31 seconds. Yeah, time taken by CPU is 31.30 seconds. Now we will do the coding for GPU. What I'm going to do is I'm going to take the same file and make a copy of it and rename it as test GPU, and open it in the IDE. Here I will need this is a test gpu.py, and here I'm going to make some small changes there. First thing I want to do is to import Numba library. So from Numba import vectorize, and just above the definition, the function which we defined as POW, we are going to vectorize that function. So add vectorize, and it's a float return, and the two arguments will be float type, so float 32 inside the bracket float 32 comma float 32, and then specify the target as is equal to cuda, which is nothing but your CUDA core processor, nothing but your GPU. And the POW function is getting to be modified as POW of A and B, and what we are going to do is just return the multiplication of A and B. The main function is also going to be modified a little bit. What I'm going to do is to call the function POW of A comma B and assign the value into C. So whenever we call this function from the CPU, function will be executed in the GPU and values are returned back to the CPU. And now I'm gonna change the text a little bit here, modify the text here, time taken by the GPU comma duration, and try to execute the program. We'll see. Let's go to the console, python test cpu.py, test gpu.py, and okay, seems like there is an error. Let me go and check on line number 5. Yeah, I forgot to close the bracket there. Okay, corrected, saved, and execute again. Time taken by GPU is 0.56 seconds, and let's try with the same with the CPU, test cpu.py. It should be the same, 32 seconds. Time taken by CPU is 32.22 seconds. Now guys, we have an understanding how to make use of vectorizing functions in Numba to make use of the power of the GPU and save your time. So let's dig in more and see what we can do with the power of GPU into your applications. Thank you. Let me wind up here, and if you have any comments or points, let me know in the comments section. Bye bye.